In general, this type of gel is required to separate single-stranded DNA or RNA fragments, such as synthesized or labeled oligonucleotides or products from enzymatic cleavage reactions. The separation range is dependent on the polyacrylamide concentration. Urea in combination with heat denatures the sample, and single-stranded molecules migrate within the gel matrix according to their molecular weight. This video presents the pouring, running and processing of a typical gel. Hello, my name is Heike Sommer. I'm with Nanyang Technological University. In this demonstration, I'm going to show you how to perform a denaturing polyacrylamide gel electrophoresis. Use clean glass plates and assemble the gel sandwich according to manufacturer's description. Fix the gel in the gel casting stand or chamber. Silanize the glass plates of large gels if the gel tends to stick to the glass plates. Choose a gel size and thickness according to your separation requirements. Prepare the gel solution according to current protocols in molecular biology. Choose the concentration of polyacrylamide that suits your separation requirements best. Higher percentage of acrylamide will resolve lower molecular weight fragments. Use ultra-pure urea and mix with the desired amount of polyacrylamide in a beaker or bottle. Add 10x TBE buffer to the solution and fill up to the required volume with water. Heat the solution for 20 seconds in the microwave and mix it gently until all urea is dissolved. You can store the solution if necessary. For larger gel volumes, repeat the microwave step until the solution is hand warm. Avoid heating the solution too much. Do not overheat because urea will start to degrade after 60 degrees centigrade. It can be detected by the smell of ammonia. When the solution is clear and has cooled to about room temperature, add APS and TEMET to the gel solution and gently mix it. If the gel solution is too warm, the gel will polymerize inside the pipette. Pour the gel using a serological pipette and a pipette aid between the two glass plates. Avoid introducing air bubbles. Insert the comb carefully, try not to trap any air bubbles, and let the gel polymerize for 30 to 60 minutes. Dismount the gel from the casting stand and assemble it to the upper buffer chamber according to manufacturer's protocol. Put the gel into the lower buffer chamber and fill the bottom reservoir with gel running buffer, which is normally 0.5 to 1x TBE, the same concentration as for the gel. Fill the upper buffer chamber with gel running buffer up to the edge of the glass plate. Before you can load your samples, you have to pre-run the gel for at least 30 minutes to heat up the gel and remove remaining urea from the gel. The optimal temperature should be between 45 to 55 degrees centigrade. Like for the actual gel run, avoid temperatures higher than 60 degrees, as bands could smear or the glass plates could crack. Carefully remove the comb without disturbing the edges and rinse the wells thoroughly to remove urea that has leached into them. Use gel loading tips and pipe it up and down several times for each well. Attach the lid of the gel system and plug in the cables to a high voltage power supply. Choose constant watts for the pre-run, about 15 to 20 watts per gel. When the power supply is switched on, air bubbles indicate good conductivity. In the meantime, prepare your samples. Therefore, add the appropriate amount of 2x gel loading mix to your sample. When the pre-run is finished, remove the lid and wash the pocket thoroughly as described before. It is very important to carefully rinse the gel pockets to remove urea residues, as urea will form a dense layer that hinders the sample from entering the gel. Right before you apply your sample, heat denature your sample by incubating it to at least 70 degrees centigrade for several minutes. Apply the samples carefully from the bottom of the pocket. For some applications, the dye interferes with your sample and can cause diffuse bands, or the dye shows a fluorescent signal. Then it is useful to remove one dye or all dyes and load the standard dye-containing buffer in an empty well as size standard. The amount of sample you should load for sharp bands is ideally between 1 to 5 microliter, but you can load higher volumes up to 15 microliters as well. Less sample volume results in nicer bands. Avoid introducing air bubbles and let the sample sink into the pocket slowly that a unified layer is formed. If you use a fluorescent label, pack the gel system into aluminum foil to prevent exposure to light, which could cause photo-bleaching of your sample. Assemble the lid and switch on the power supply. Run the gel until the die front reaches the lower end of the gel. The run duration is dependent on the percentage of acrylamide you choose, ionic strength of your buffer, gel thickness and length. A run can last between 1 to several hours. Observe the migration of the marker dies to determine the electrophoresis duration. Use constant watts and check the temperature on the gel. A gel thermometer can help to monitor the right temperature during the run or check the manual of the gel apparatus. When the die front has reached the end, switch off the power supply and remove the lid of the gel apparatus. Next, put the gel sandwich out of the lower buffer chamber. Pour away the buffer from the upper buffer chamber. Fill the dish with gel fixation solution. This solution should have the same concentration of TBE and between 5 to 10% methanol and acetic acid. Remove the gel sandwich from the apparatus and loosen the clamps. Pull away the spacers and carefully disassemble the glass plates using a spatula. If necessary, cut away the upper well-containing gel part or the lower empty gel part and discard the needless gel pieces like dye-containing lanes for fluorescent samples. Carefully detach the gel from the glass plate and transfer it into a dish filled with gel fixation solution. Leave the gel into the solution for 5 to 10 minutes and change the buffer twice. Gently agitate the dish to wash out the urea from the gel, or put the gel in staining solution depending on your application. The gel quality is also dependent on the gel thickness. Thinner gels like 0.75 mm show better results than 1.5 mm thick gels, but are more difficult to handle. The sharpness of the bands depends on several factors. Low voltage at the beginning of the run can help to get nicer bands as well, as the sample enters the gel front smoothly and this avoids that the gel pockets collapse due to high voltage. A short low percentage acrylamide stacking gel can have the same band sharpening effect. Including 10% glycerol also helps during the gel loading and the sample sinks into the well more easily. Apply a loading buffer to empty pockets to maintain equal conditions during the run. When your gel is in fixation solution, you can dry your gel using a vacuum gel dryer for further imaging or scan your gel directly, depending on label, dye or stain you are using. This urea page is useful to analyze or isolate single-stranded DNA or RNA samples. Gels can be stored at room temperature. Therefore, wrap the gel in paper towel and soak it with water or running buffer. Put the wrapped and wet gel into a sealable plastic bag and use it within 48 hours. An often observed problem is gel smiling. This is due to uneven heat distribution through the gel. If the gel is not surrounded by buffer, attaching of a metal plate can increase the quality of the gel.
Hi, I'm Heike Sommer. I'm with Nanyang Technological University. I showed you how to perform a denaturing polyacrylamide gel electrophoresis. See you next time.